Okay, in part 3, we're going to quickly review vertical and horizontal lines, and then we're going to see how we use this to determine whether lines are parallel, perpendicular, or neither. So a quick review, vertical line, vertical is up and down, it's written in the form x equals a. A is going to be some number where the line crosses the x-intercept, or crosses the x-axis. So if I look at this one, this is my vertical line. The equation is going to be x equals, and then wherever it crosses right here on the x-axis, that's the number that goes there. As we learned earlier, any line that is vertical is always going to be undefined slope. Horizontal lines are always written in the y equals a number. So if I look at this equation, here's my x and y axis. This is my line that I'm talking about. It crosses the y-axis right here at 1, 2, positive 3. So y equals 3 would be the equation of that line, and the slope would be 0. Any line that is horizontal will have 0 slope. So when I go to graph them, it's a pretty simple way to go through it. Y equals 4. I know it has to cross the y-axis at 4. So here's my y-axis, 1, 2, 3, 4, and then it's going to go the other way because a y equals will always be horizontal. So it's kind of like count and then go the other way. Okay, so if I'm counting up, then I'm going left and right. On this one, it's going to cross the x-axis at -2, so I count and then I go the other way. So you see I counted to -2, and then I'm going up and down because x equals will always be vertical. Y equals 0 is where does it cross the y-axis at 0? Well, that's right here at this point, right? So the y equals 0 is the same thing, because it goes through here, as the x-axis. The line that I just drew intersects the y-axis at 0. It also happens to be the x-axis. So let's go through a couple of things here. This is our last little piece. So when I'm looking at equations, how can I determine whether the lines, without graphing them or anything, are parallel, perpendicular, or neither? It all boils down to their slope. So reminder from a previous lesson, parallel lines have slopes that are exactly the same. Perpendicular lines have slopes that are negative reciprocals of each other, which basically means they have to be the opposite sign in reciprocals. If a line is y equals a number, that slope is going to be 0. And if it's x equals a number, that slope is going to be undefined. Now, I've gone through and I've given the conversions of some of these that are in standard form. I converted them already to slope-intercept form. So let's just take a look. If I want to determine, so this equation is in slope-intercept, so that slope is 5. This slope is 5. If the slopes are exactly the same, these are parallel. The slope of this line, it's already in slope-intercept form, is -3/2. The slope of this one is 2/3. Well, I can see they're not the same. Are they opposite negative reciprocals of each other? Opposite signs. 3/2 flipped is 2/3, so that means they are perpendicular. Now on number 20, you can see they give us the equations in standard form. We've already shown you in a previous notes, I think it was part 2 or part 1, how you change from a standard form into a slope-intercept form. So I've already done this for you. So when I change this one, this is my slope-intercept. Means my slope is -1/2 for that line. Here's my slope-intercept form for this one, and that slope is 2. I always like to do 2/1 just because it reminds me. So they're not the same, so it's not parallel. So to check perpendicular, is the fraction flipped? Yes. Are they opposite signs? Yes. That's perpendicular. If one of those answers was no, it'd be in neither. Change this one. The slope of this line is +1. The slope of this line is +1, exactly the same, parallel. I converted this standard form into slope-intercept, where the slope of this one is 3. This one is already in the right form. The slope of that one is 1/3. Well, we can see they're not exactly the same. But are they reciprocals of each other? Well, 3 is like 3/1, so yes, they flip each other over, or they are the reciprocals, but they are the same sign. So that would be, they are neither parallel or perpendicular. Converted, so the slope of this one is 2/3. The slope of this one is -3/2. They are reciprocals. 2/3 is 3/2, and they are opposite signs, so they are perpendicular. You know, as you're going through here, you might want to stop the video, copy these equations down, because it does you no good just to copy these answers of neither or parallel or perpendicular. You need to have these equations down so you can see where the slopes came from, and from the slopes resulted in which one this is. Okay, so don't just write down those answers. You want all the work that's going in there. The slope of this one is -1/4. The slope of this one is -1/4, exactly the same, parallel. Slope of this one is -4. The slope of this one is -4. So that means they're exactly the same. That is parallel. Okay? Now we're coming up here. This one says y equals and this one says x equals. Well, I know one of them's vertical and one of them's horizontal. In fact, a y equals is going to be a line here, and an x equals is going to be a line this way. So those two lines are going to be perpendicular. This one is an x equals and an x equals. An x equals is always going to be vertical. So here's one of them and here's the other. So they are going to be parallel to each other. So again, I would encourage you, especially if you need to have some practice where you're converting standard into slope-intercept. There's a little bit more practice there. When you get to that slope-intercept, then you can identify the slopes of each line, and it's from there that you determine parallel, perpendicular, or neither. So if you have any questions, let me know.